Chapter 4, Applications of Differentiation. Let's discuss 4.3 Rates of change. Learning outcomes, find related rates of change. Let's take a look at the quick view definition. Rate of change of quantity Q, dQ per dt means that the rate of change of Q with respect to time t. While if the rate of change is positive, it means the quantity is increasing with time, and if the rate of change is negative, it means the quantity is decreasing with time. How to find related rates of change? First, we need to name all the variables and constants and write down the numerical information and what you are asked to find. Second, write the equations that relates to the variable before. And third, use the chain rule, differentiate the equations that you have before and evaluate the answer. Chain rule only involves a pair, two variables of major and minor, where major is area, volume or circumference, and minor is radius, height or width. Let's discuss example 1. A cylindrical tank has a base with radius r equals to 2 meter. The tank is filled with water at the rate of 2 meter cubed per minute. Find the rate of change of the water level in the tank. First, we come out with the sketching of the cylindrical tank with the radius r there and the height of the water level denoted as h. Given that dV dt equals to 2 meter cubed per minute and radius equals to 2 meter. So we need to find the rate of change of the water level in the tank, which is actually referring to dH dt. Let V be the volume of the water in the tank. Since we have our solid now is cylindrical tank, so volume is pi r square h. Okay, we substitute r equals to 2, so we will have 4 pi h. Then we find dV dH, which is equals to 4 pi. Then we come up with the chain rule, which is we need to find dH dt equals to dH dV times dV dt. Since we have dV dH equals to 4 pi, that means we need to substitute dH dV is 1 over 4 pi. Multiply with dV dt is 2. So we will have 1 over 2 pi. So the water level increase at the rate of 1 over 2 pi meter per minute. Example 2, the figure shows a right circular cone and oil is pumped into the tank with the fixed rates of 45 meter cubed per minute. Find the rate of change of height of the oil when the oil level is 3 meter deep. State the answer in 3 decimal places. Based on the figure, we have the radius of the cone is 30 and the height of the cone is 8. Given in the questions, dV dt is mentioned as 45 meter cubed per minute. We need to find dH dt because the question state that find the rate of change of height of the oil. So that means we need to find dH dt when h equals to 3 meter deep. Okay, based on our new sketching, we denote here as r for the radius for the oil and h as the height for the oil. So we will have r over h equals to 30 over 8. We compare with the big cone here. So we will have r equals to 30 over 8h. Let V be the volume of oil in the tank. So we have V equals to 1 over 3 pi r square h. Then we substitute r equals to 30 over 8h. Okay, then we simplify, we will have 75 over 16 pi h cubed. Then we construct our chain rule. We have dH dt equals to dH dV times dV dt. Note that V equals to 75 over 16 pi h cubed. So we need to find dV dH first, which we will have 225 over 16 pi h square. But we need to substitute dH dV. So we need to change the positions. So we will have 16 over 225 pi h squared. When h equals to 3, we substitute everything into the chain rule. We will have dH dt equals to dH dV, which is 16 over 225 pi h squared. So we substitute directly h equals to 3 and then times 45, which is dv dt. Then we will have 0.113 meter per minute. Let's discuss example 3. Gas is escaping from a spherical balloon at the rate of 2 cm³ per minute. How fast is the surface area shrinking when the radius is 12 cm? Given dv dt equals -2 because the surface area is shrinking and also the volume. So we need to find the dA dt when r equals to 12. Volume of sphere, given that v equals to 4/3 pi r cube, then our dv dr equals to 4 pi r square. While surface area for sphere is a equals to 4 pi r square, then dA dr equals to 8 pi r. We need to find dA dt. Okay, based on our chain rule, dA dt equals to dA dv times dv dt. But we don't have dA dv. So we need to come up with another chain rule, which is dA dt is actually equals to dA dr times dr dv times dv dt. So we continue our solution since dA dt equals to dA dr times dr dv multiply with dv dt. So we substitute our dA dr given as 8 pi r. Okay, so we have dv dr. So since we need dr dv, so we just rotate it. We will have 1/4 pi r square multiply with dv dt given is -2. So we cancel out, we simplify, we will have -4/r. Then we substitute r equals to 12, we will have -1/3. So surface area is shrinking at the rate of 1/3 cm² per minute. Please try this exercise and refer to the answer given. Okay guys, so this is the test yourself questions. It's quite challenging. You try it first and after that try to refer with the answers provided in the YouTube by the producer of the questions. Actually, these questions is from the internet and please refer to the YouTube channel for this given link and try to check your answer. That's mean we finish with chapter 4. Thank you guys.